Hello, my name is Ian Dowdy, and this is Objective 1 for Assignment 4. So starting off with the board itself, the new stuff, we have a jumper running to a button. The button on either side from here and here are not connected, and when you press it, it connects them. That's basically what it does. And then we have the pull-down resistor next to our jumper wire to pin 7, and the pull-down resistor just ensures a low default state, so you don't get like noise or erroneous data read uh, from from the input into pin 7, which we'll go over in a second. But that's about it for the board. Um, so declare and initialize a bunch of variables. The new guy here is byte. Basically just tells Arduino to reserve 8 bits in storage. They're unsigned. It can be a value, I believe, from 0 to 255. So we declare last button state, and we declare an initialize pattern with at 0. The new stuff in the setup is our input, and basically if output is driving voltage, like an 8, 9, 10, if it's driving voltage to these LEDs, input is reading voltage from this jumper from here to here, from pin whatever voltage is being put into pin 7. And so it just reads voltage, and we use that in conjunction with digital read, which reads the state either low or high. So we initialize our last button state, and it reads button, which is, like I just said, pin 7, and it'll initially be low, assuming, I guess, you're not pressing it when it starts. Millis is just a timestamp from the Arduino board is booted, and so, and during the setup, this is ran once, so it timestamps it like almost immediately when the board when the setup is run. So moving into the loop. So it takes a timestamp every loop, and it's subtracted from that last time that button state change, which is initially when it started. So basically, if that's greater or equal than our debounce duration, which is 50 milliseconds, the rest of this will run. And basically, it's just I don't want to say validation, but it is sort of like a safety, so that you can't just like from it, right? It doesn't read like multiple inputs from one press. So you don't press it once and it jumps from like pattern 0 to pattern 5 or whatever. Moving on, current button state. So yeah, it'll read. Let's see. Yeah. Okay. So during this if statement, it will check what the state of pin 7 is, and if pin 7 is different from the last button, which we initialized at the very start of, which should be low, if it's different, so if you've pressed the button, if you've changed its state, last time button state change, it's timestamped again with millis, and then the last button state is set to the current. Now, if the current button state is equal to high, then we increment the pattern, and then if that pattern goes above 7, it's just instantly set to 0. And so what happens is, to say let go of the button, and so the current button, the state's changed. It's changed from high to low. So it runs it again, reads it to low. Current button state is low, and it's different from what it last was because this runs like however many thousands of times a second. So it sets to low. It takes another timestamp, and then it sets it back from high to what it compared it to low. But since it's not high anymore, none of this executes. Okay, moving on. This, so this conditional pattern starts off at 0, 0, 0, and 0b just means any numbers after this are just to be interpreted, written in binary. It just means the rest of this is written in binary. And so pattern is at 0, it'll be read as 0, 0, 0, and then we explicitly say right here, compare it to 0, 0, 1. And the way I believe C does this comparison is it compares each bit individually. And so what that means is if we're at pattern is 0, 0, 0, and we're comparing it with, we need 0, 0, 0 and 0, 0, 1, it'll be false, because that is, it's none of these are like true. I'm sorry, poor way to explain it, but let's say let's do like 3, right? So that's 3 is 0, 1, 1. So if 0, 0, 1, 1, and then 0, 0, 1, it compares each 0 to 0, 1 to 0, 1 to 1, and one of those is true, it'll interpret it as true. So for 3, 0, 1, 1, this is true because 0 to 0, 1 to 0, but 1 to 1 is true, so LED will turn on. And then, so that's why red would turn on too, is because red is set to 3, or not 3, 2. And so we have 0, 0, 1, 1, 0, 0, 1, 1 is true, so automatically it'll turn on. And then, yeah, it's the same logic for all 3. And so what ends up happening is that if since it's directly comparing those bits, if one of them is included in pattern, it'll register as true. And if it isn't, if it'll register as true and it'll turn on. And if it's not there, it'll register, it won't. It'll be false, and the else will run, and it'll turn to low. Basically what ends up happening is 1, 2, 3, 4, 5, 6, 7, repeat. 1, 2, 3, 4, 5, 6, 7, repeat. Okay. And that should be it. Thank you. See you in objective 2.